Welcome to day 12 of our low-level design course. Today we are going to explore two very important design patterns, the singleton pattern and the builder pattern. These patterns are frequently used in object-oriented design to solve real-world problems involving object creation and management. Understanding these patterns will allow us to design more efficient, maintainable, and flexible systems. Let's dive in and see how these patterns help streamline the way we build and manage objects in software design. By the end of today's session, you will be able to understand the core principles behind the singleton and builder patterns, identify when and where to use these patterns in real-world applications, gain hands-on experience through coding exercises which will help you implement these patterns in your own projects. We will also look at potential challenges and pitfalls of these patterns, ensuring that you can apply them effectively. Let's get started with a quick review of where we left off yesterday. Before we dive into today's patterns, let's quickly recap what we have learned yesterday about the factory and abstract factory patterns. Both of these patterns help us create objects without exposing the instantiation logic to the client. This focuses on creating families of related objects. Now, as we look at singleton and builder patterns, we will shift focus from object creation to managing object instances and structuring complex object construction. These are equally important in creating clean, maintainable designs. Let's begin with the singleton pattern. To understand the problem it solves, imagine you are designing a logging system for a large-scale application. You want to ensure that there is only one instance of the logger class to avoid inconsistent logging behaviors. If you create multiple instances of the logger, it could result in duplicate logs or even performance issues due to unnecessary object creation. The singleton pattern is designed specifically to address this problem, ensuring that a class has only one instance and providing a global point of access to that instance. The singleton pattern ensures that a class has only one instance and provides a global point of access to that instance. This is achieved by making the constructor of the class private, preventing direct instantiation. Instead, a static method is used to return the single instance of the class. It's typically used in scenarios where having multiple instances of a class would lead to undecidable outcomes, such as in the case of a configuration manager, database connection pool, or logging system. The singleton pattern is perfect for ensuring global consistency and saving resources in your system. There are several ways to implement the singleton pattern, each with its own advantages and trade-offs. Let's go over a few common approaches. Lazy initialization. In this approach, the instance of the singleton class is created only when it's needed for the first time. This is efficient in terms of memory usage. Thread-safe singleton. When working with multi-threaded applications, ensuring that only one instance is created is crucial. In a thread-safe singleton, additional synchronization mechanisms like locks or mutexes are used to ensure thread safety during the instance creation. Eager instantiation. The instance is created when the class is loaded and no further synchronization is needed. This approach is simple but may be less efficient if the object creation is resource intensive. Build path singleton. This method uses the initialization on-demand holder idiom, leveraging the class loader mechanism in Java to ensure that the singleton instance is created lazily but safely. To see the singleton pattern in action, let's look at a few real-world examples. Logger systems. Often we need a single centralized logger that handles all log messages throughout an application. Having multiple instances of the logger could lead to inconsistent log messages. Database connection pools. A connection is a limited resource in your application. You don't want to create new connections every time you need one. So a singleton connection pool manages all the database connections, ensuring there's only one instance of the pool. Configuration managers. Many applications have configuration settings that need to be accessed globally. Using a singleton ensures that the configuration is loaded only once and used consistently throughout the application. While the singleton pattern can be very powerful, it's important to use it wisely. There are a few common pitfalls to watch out for. Hidden dependencies. Other parts of your code may become tightly coupled to the singleton instance, making it difficult to test or modify. Global state. The singleton instance represents a global state, which can be problematic in multi-threaded environments if not implemented carefully. Difficulty in unit testing. Since the singleton enforces a global instance, it can become challenging to write unit tests that isolate the behavior of components. Best practices include minimizing the use of singletons, keeping the patterns encapsulated, and ensuring that dependencies are injected rather than directly accessed. Now it's time for you to implement a singleton pattern. Your task is to create a singleton logger class. Try to implement it using lazy initialization first. Once you have completed that, experiment with making the implementation thread safe. This exercise will give you practical experience in applying the singleton pattern and understanding its nuances in different environments. Now let's shift focus to the builder pattern. Suppose you are designing a pizza builder. A pizza might have a number of optional toppings like cheese, mushrooms, olives, and others. Without the builder pattern, the code could quickly become messy with multiple constructors or methods that take numerous parameters. This leads to confusion and lack of clarity in object creation. The builder pattern solves this problem by allowing us to construct complex objects step by step, and more importantly, it makes the code cleaner and easier to understand. The builder pattern separates the construction of an object from its representation. It lets us create an object step by step using a builder class. The builder class defines the different steps in constructing the object, while the product is built progressively, giving us control over the construction process. The builder pattern is especially useful when you have an object with many optional parts or when the object creation process is complex and needs flexibility. Here's the structure of the builder pattern in UML. You will notice that we have the director class which manages the construction process. It uses the builder interface to call the appropriate methods. The concrete builder implements the builder interface and defines the exact steps of building the object. Finally, the product class represents the constructed object. This clear separation of concerns is one of the strengths of the builder pattern, making it easy to manage complex object creation. Let's walk through an example of how the builder pattern works. Imagine you are building a house. You might have a house builder class with methods like add room, add garage, and add swimming pool. Instead of passing all the possible components to a constructor, the house builder allows us to build the house step by step. Once you have finished adding the components, you can call .build to construct the final house object. This makes the object creation process more intuitive and flexible. Real-world examples of the builder pattern include string builder in Java, which allows us to efficiently build strings without creating multiple immediate string objects. Similarly, HTTP request builders in libraries like OKHTTP let us create complex HTTP requests with many parameters like headers and body data. Another great example is UI frameworks where components like buttons, text fields, and layouts are constructed using a builder, making UI creation both clear and flexible. Let's try out the builder pattern in practice. Your task is to create a pizza builder. This builder should allow customers to customize a pizza by selecting different sizes, toppings, and sauces. The director class will manage the pizza creation process and provide several predefined recipes. This exercise will give us hands-on experience with the builder pattern and show us how it simplifies object construction. Before we wrap up, let's quickly compare the singleton and builder patterns. The singleton pattern focuses on ensuring a single instance of a class and controlling global access to it. It's ideal when you need a single shared resource like a logger or configuration manager. The builder pattern, on the other hand, is focused on constructing complex objects step by step. It's perfect for objects with multiple optional components and helps maintain clarity in object creation. These two patterns solve different problems but are both crucial tools in any software design toolkit. For today's assignment, I have 3 tasks for you. Implement a database connection manager using the singleton pattern. Create a computer builder that allows a configuration of a computer with different components like CPU, RAM, and storage. Reflect on the drawbacks of the singleton pattern and write about scenarios where its use might cause issues in a design. Complete these exercises to reinforce your understanding of both patterns. Let's summarize what we have learned today. The singleton pattern ensures that a class has only one instance and provides global access to it, making it great for shared resources like loggers. The builder pattern allows for flexible, step-by-step construction of complex objects, making it ideal for objects with multiple optional parts. Both patterns play a vital role in designing robust and scalable systems. Keep practicing and you will soon be able to recognize where and how to use these patterns in your own projects. Thank you for your attention.